to learn a little bit about cost behavior. And by the time we're finished with this chapter, you should be very familiar with what variable, fixed, and mixed costs are. So for a cost to be variable, it must be variable with respect to something. And we're going to get to defining what variable means in just a second, but that something is going to be the activity base. So an activity base, or also known as a cost driver, is a measure of what causes the incurrence of variable costs. As the level of the activity base increases, the total variable cost is going to increase proportionately. Of course, cost behavior below is defined as the way in which costs change in response to changes in the measure of an activity. So an activity base, for example, might be the number of units that we produce, right? So the more units units that we produce, obviously the more direct labor and direct materials are going to be consumed. And cost structure is the proportion of fixed, variable, and mixed costs that a company has. And we'll talk about, like I said, and define each of those here in just a moment. So we're going to define what relevant range is here. It says specifying the range of activity over which the changes in the cost are of interest is called the relevant range. And so I guess the best way to think about this is if we're thinking about the cost of a factory building, and let's say in that factory building we could make anywhere from 0 to 2 million units of a product. So the cost of that factory, it's already been paid for, right? And we are depreciating it, or maybe we don't have it paid for. That part doesn't really matter, but the fact is, if we don't make any units of product, we're still going to have that same cost for the factory. We can make 10, 150,000, 1.5 million. It doesn't matter. The cost of that building is still going to be the same thing. So it's fixed, meaning it's not going to change based on the level of activity for that relevant range. Like I said, we're assuming from 0 to 2 million products, and let's say our product became in high demand all of a sudden, and we needed to make 20 million. Well, at that point, that's beyond the relevant range, right? So at that point, we'd have to look into expanding and doing something else. So when we're saying that the cost of the factory is fixed, we're talking about over a specific relevant range. And as we move along through the next couple slides, I'll make sure to point some of that out so that of some of the places where we can see a better example of what the relevant range is. Hopefully that'll help you out a little bit. So let's take a look here. It says Jason Sound Incorporated produces stereo systems, and the parts are $10 per unit that they put in those, and Jason Sound Incorporated is going to put those together. So we can see here we have direct materials of $10 per unit. If we make 5,000 units, it's going to take 5,000 times 10, so it's going to take $50,000 direct material cost. All the way on up here to 30,000 units, it's going to take still $10 per unit, which is going to be a total of 300,000. Okay, so we can see here that the amount of direct materials varies based on the level of this activity driver, right? And the variable cost per unit is going to be the exact same, isn't it? So variable costs are costs that vary in proportion to changes in the level of the activity. And as we saw a second ago, direct material and direct labor are normally variable costs. So if we look here, remember it was $10 per unit, so we have 10,000 units there, $10 per piece. We're looking at 100,000 units. So we can see how this increases, right? This is the total variable cost, right? But remember, per unit, it always stayed the same, $10 per unit, right? So this is our relevant range over 0 to 30,000. It's going to stay $10 per unit. And what if we got over 30,000? Then perhaps the per unit price is going to drop a little bit because we're purchasing so many of those components. Maybe it drops down to like $9.70 or something like that. But this is our relevant range there, 0 to 30,000. We can see that once again right here. We're going to take a look at some fixed costs now. So Minton Incorporated manufactures bottles and distributes perfume. The production supervisor is Jane. She's paid $75,000 per year, and that plant produces from 50,000 to 300,000 bottles of this perfume. So regardless of how many they make, she's getting paid the same amount, $75,000, right? So we can see here, this is the relevant range from 50,000 to 300,000 in this example, and for her it's going to be the same, 75,000 bucks. Now we can see if we spread her fixed cost out over the number of bottles, as the number of bottles goes up, the fixed cost per unit goes down, right? Let's take a look here. We can see that the total fixed cost stays the same, but see here the relevant range from there to here. Over the relevant range, the more we make, the less per unit we're looking at there, right? So that's a unit fixed cost graph. Mixed costs, sometimes called semi-variable or semi-fixed cost, they're going to have the characteristics of both variable and fixed, right? So over one level of activity, the total mixed cost may remain the same, and over another level, it may change in proportion to changes in the level of activity. So let's take a look here. It says Simpson Incorporated manufactures sales using rented equipment. So the rental charges are $15,000 per year, plus $1 for each machine the hour is used over 10,000 hours, right? So at first it says 15,000 bucks for the first 10,000 hours. We can see that. So it's fixed here initially, and then it goes up, right? So if we had a 0 to 10,000, if our relevant range was only 0 to 10,000, this would look like it's totally fixed, right? But our relevant range is from 0 to 40,000. So we know it's fixed initially, and then it's variable at that point, isn't it? So if we have a mixed cost, it's helpful to be able to plot it on a graph like that, and it's nice to know what component of it is fixed and what component of it is variable. And one way to do that here is the high-low method, right? So that's an estimation method that's used for separating these mixed costs into those two components. So with this, the way this method works is we're going to have some information here about what our production levels are and what the total cost was. So we can look at these actual costs incurred and gather some of this information together. So we take the highest point, let's see there, it looks like 21,000, doesn't it? And the lowest point is at 7,500. Okay? And we can see here that the difference between those two amounts is $20,250. So we're going to divide the difference in the dollar amount by the difference in the production number of units produced. So we take this 20,250 divided by 1,350. It's going to give us $15. So our variable cost is going to be $15 per unit. Now make sure you actually choose the highest and lowest level of activity, otherwise the figure you calculate is not going to be correct. So we figured out that it was 15 bucks. Remember, 15 bucks is the variable component. And so then the next step we're going to have here is to insert the variable cost of $15 into the following formula. So the total cost is going to be equal to the variable cost per unit. In this case, it was 15 times the units of production plus the fixed cost. So we see here we're going to take one of these. It doesn't matter if we use the high or low. So we're just going to take the highest in this example. So using the highest level of production, we can insert the total cost and the units produced into that formula. So we know that the total cost was 61,500. So we plug that in here, and that's going to equal the $15, the variable component per unit, times $2,100. And so, And so here we are here, and we can see here that once we plug all these numbers in and multiply those two guys together, we have 61,500 equals this plus the fixed cost. When we solve it, we get $30,000 is the fixed cost. So if the lowest level had been chosen, the results would have gotten the same. You just either pick one of them, the high or the low, and we happen to choose the high one to work this out. Okay, so if we look back there a second ago, remember 30,000 is the fixed cost and 15 is the variable cost per unit, right? So now we can create a formula to estimate the production at any level. So if the company is expected to produce 950 units, we can go ahead and estimate that out to figure out what the total cost is going to be. 30,000 is our fixed cost. So this is, no matter what the levels of activity are, this is going to be incurred, right? At least within that relevant range. So we have 30,000 as our fixed cost and $15 per unit times 950. So when we add all that together, we're going to get $44,250. So it's a really cool tool to be able to estimate what the total costs are going to be. Let me take a second here to talk also about step variable costs. So basically, step variable costs are fixed over a small volume range, but are variable over a large volume range. So if we had a really narrow relevant range here, we don't even have numbers on this, it's just something I threw together to show you. But if we had a really narrow relevant range, this might look like it was fixed. But that would be like way too small of a sliver here. So within the normal level of activity, it might be, fixed here, fixed here, fixed here, fixed here. So for example, supervision costs are fixed for a given range of production volume, but increased production often requires the hiring of additional supervisors. So maybe each supervisor can supervise 10 people working on the assembly line, right? So if as production increases and we need more people, these are fixed, then it has to go up to get another supervisor for another 10 people. It's good for 10 more until we get past that point, and we need to keep going up like that, right? So that's very different. There's all types of different graphs we could put together to show different types of costs, but these are some of the more common. I'd like to take a minute here to talk about the contribution margin. And what the contribution margin is, it's simply the difference between the sales and the variable cost, right? And this is pretty cool because like I said before, as you can see here, it's very useful in providing insight into the profit potential of a company. So let's take a look here. Just if we were given this information, we can see if we had sales at this level and that price, and the variable cost, contribution margin is $400,000. Our fixed cost in this example here, it's $300,000. So, no matter what the activity level is, we're going to have that $300,000. So this is kind of cool because this is the part we can control, right? I mean, we can sell more and produce more, but those fixed costs are going to stay the same. So in this example, the income from operations is $100,000. So another way to think of it is you have to have enough contribution margin to cover your fixed costs, and anything left over that is going to go into the income from operations. We can plug this into this formula here to come up with the contribution margin ratio. I'm sorry, I got tongue twisted there. And we can also, like I said, do a couple cool things with this. I don't want this video to go too terribly long, so I want to kind of breeze through some of this here. It's there for you to take a look at, of course. But once we have that contribution margin ratio, we can use that to do some estimating. So the break-even point is the level of operations at which a company's revenues and expenses are equal. Sounds pretty simple, right? So revenues are equal cost. There's no profit at that point. The profit is zero. There's no loss. And there's no profit either. So we can see here in this example, we can think of contribution margin in an amount per unit as well. And in this example where we're given $990,000 as being the fixed cost and our unit selling price is $25 and unit variable cost are 15 and our unit contribution margin is 10, we can use this information to come up with a estimation of what our break-even point is going to be, right? So if we have fixed cost of $90,000, we can see that here, and we divide that by the unit contribution margin, we're going to break even at the point where we have 9,000 units that we sell, right? So this is pretty handy if we want to know how many we have to sell to at least break even. This is a really easy way to estimate it, right? So you can think about it like this way. Remember, once the fixed costs are covered, anything else is going to go into the profit of the company. So they have this $90,000 is going to be incurred no matter what, even if they don't produce anything. And we're making the difference between the sales and the variable cost is $10 per unit. So this is like the unit profit. You can think about that, right? So it's the unit contribution margin, the difference between the sales per unit and the variable cost per unit. So in this case, we can think it's probably direct materials and direct labor and anything like that. So that 90,000 divided by the 10 is how we came up with 9,000. You can pause this here if you like to. This is proof of the preceding computation. Feel free to pause and take a look at this as well. I'd like to take a moment here to discuss a CVP chart, or cost volume profit, or a break-even chart, right? So it graphically shows sales, cost, and the related profit or loss for various levels of units sold. So this is kind of neat here. We can see just all sorts of stuff here. It looks pretty busy at first, doesn't it? So we can see the break-even point is where this line that represents total sales intersects the line where we have our total cost. And at this point, there's no profit and there's no loss, right? To the left of here, this is where we're losing money. And the difference between these two is the difference between is how short our sales were at meeting total cost. And here, it's the point of the operating profit area here shows where our total sales exceeded our total costs. So along the bottom here, it says 1,000, 2,000, 3,000, 4,000, 5. This is the units of sales down here at the bottom, and over to the left, we have the sales and costs, right? So that's the on the y-axis, the sales and costs. So here's the sales, it's this red line, and the total cost is this red line coming down. So we can see from looking at this that the fixed cost here must be $100,000, right? Because the cost, even if we don't produce anything, even at this level 0 here, we're still going to incur $100,000 worth of cost, right? And then from that point, anything else that increases the number of units here, as those number of units increase, we see that the total costs are going to rise as well. So this first part, the place that intersects the y-axis, that's the fixed cost, and then over here, the slope of this represents the total variable costs. We're also going to see something here called a profit volume chart. Now this is only going to show the difference between total sales and total costs or profits, but this might be something else that you see. So in this example, we're going to have a unit selling price of $50, unit variable cost of $30. So our unit contribution margin is going to be $20, and our total fixed costs are going to be $100,000. So here it says the maximum operating loss is equal to the fixed cost of $100,000. So if we don't produce anything, we're still going to have $100,000 of fixed cost, right? Now if we produce more than that, we're going to incur some variable costs, but at the level of 0, we're going to have $100,000 of fixed cost, okay? So assuming that the maximum unit sales are within the relevant range of 10,000 units, the maximum profit is $100,000 as computed below. Oops, there's a comma there. That shouldn't be there. Sorry, it should be a period. So as we saw, as we calculated just on the last slide there, we can see here that this is the maximum we can lose is 100,000. If we don't do anything, we're still going to have 100,000 in cost, right? And the most we stand to gain at that level, given all the parameters that we're working within, is 100,000 as well, right? So the place where our profit crosses this 0 here, that represents our break-even point. Over here, this is our operating loss area, and by the way, that break-even point, if we come down here, we can see it's right above the 5,000. So as we can see from the chart, at the break-even point, 5,000 units, that's where profit equals 0. And if we went over here and scooted over to here to 8,000, okay, we would see that our profit would be 60,000 right there, right? Let's take a look at what it would look like if we had a revision to our maximum profit, right? So if we had an increase in our fixed costs, we would see it's going to move our break-even point from 5,000 to 6,000, as shown right here, right? It slid this line over to the right here, and so at that point now it was over here, but our break-even point now is slid over to the right a little bit. Okay. I know we covered a lot in this video, but thank you for taking the time to listen to it. Please let me know if you have any questions at all, and good luck.